Assalamu alaikum. Welcome to the course Fundamental of Analytical Chemistry. So before going to discuss units of concentration, we all are aware of the fact that in analytical chemistry for sample preparation you must know some basic idea about the preparation of samples, or when you analyze a sample you must know something prior to its analysis. Like for any sample we must know the units of concentration. Here what we mean by units of concentration, actually in analytical chemistry the sample is represented by any quantitative units so that everyone get information about the amount of analyte in a particular sample. So concentration, you know that it is actually the amount of solute dissolved in a given amount of a solution. How much amount of solute is present in a given amount of a solution? This solute, we know that it is like an analyte. So first step is a preparation of sample of known concentration, and with the help of this known concentration we have to determine the concentration of an unknown analyte. So we have different ways to prepare a solution of different concentration, or you can say we have different units that are used to quantify a particular analyte in a given sample. So the units are normality, molarity, molality, parts per million, parts per billion, parts per trillion, mole fraction, mass fraction, percent weight by volume, percent volume by volume, percent volume by weight. We will be discussing each and every unit of concentration in detail. First one is normality or normal solution. We are aware of the fact that actually normality is the number of gram equivalent of solute present in 1 liter of solution. The solution of such concentration is called a normal solution. So a normal solution is defined as a solution that contains 1 gram equivalent, or you can say 1 equivalent of that substance per liter of this solution. It is actually represented by N, so we can say that one normal solution is actually like if you dissolve 36.5 gram of HCl in 1 liter, then the solution will be 1 normal. Or if you have an HCl solution that contains 1 gram of hydrogen ion, mean their solution will be 1 normal. Okay. Here normality is similar to molarity, except that in normality we are dealing with equivalent weight, whereas in molarity we are dealing with the moles per liter. So actually normality is the number of gram equivalent per liter of a solution. Well, a normal solution here we can represent it as 36 by 5 HCl divided by 1 liter of a solution. Now, what is number of gram equivalent? Question might be in your mind that what is number of gram equivalent? Actually, the number of gram equivalent is equal to the weight of a substance in gram divided by its equivalent weight. Now again you will be thinking that what is equivalent weight? Let's wait and let's see. Okay, so number of gram equivalent is equal to amount of the solute in grams or mass of solute divided by equivalent weight in gram of solute. So the number of gram equivalent is just like, analogous to the formula of moles. We say like number of moles equal to mass per molar mass, or you can say molecular weight. So these two formulas are like analogous to each other with slight changes. By the equation 2 we can write equation 1 as equation 3 and 4. Okay, to determine the number of gram equivalent weight in substance, the gram equivalent is divided by its calculated equivalent weight is shown here, and we will be dealing with the equation in the previous slide later on. So what is number of gram equivalent? Suppose we have sodium chloride. Here we have its molecular mass, as you can see, formula mass. Because for ionic compound we use the word formula mass, and for molecular compound we use the word molecular mass. Okay, divide by 58.8. Here this one is an equivalent weight. It gives us 1 gram equivalent. Okay, a number of gram equivalent for 20, if we have 29.5 gram of sodium chloride, the number of gram equivalent will be 0.5 gram equivalent. Now, by using question 2, 1 and 2, we can just find another equation where the normality is equal to amount of solute in grams divided by equivalent weight per liter of solution, and we know that equivalent weight is equal to here the equivalent weight, actually it is equal to molar mass divided by x. In this equivalent weight is equal to molar mass divided by x. This x may be any replaceable entity. It may be proton given by the acid, it may be hydroxyl ion given by the base, it may be number of electron gain or lost. We will be talking about it later on. While the above formula is just like you can say it is based on law of equivalent weight. Here you can go for electrochemistry. This concept has been taken from electrochemistry, where you can check at some detail electrochemistry. Okay, I am just a little bit slow in writing. Chemistry. Okay, and why? So you can find this one in electrochemistry. Now, what actually it state? It state that the substances react in the ratio of their equivalent weight. How? Suppose we have sodium chloride. Its equivalent weight is 40 gram. How? Because the molar mass is 40 gram, the number of replaceable entity here is 1 OH. So 40 divided by 1 is equal to, it is 1. 40 divided by 1 is equal to 40. So equivalent weight must be 40. Again, in case of H2SO4, here 2 replaceable protons. 2. You can say it gives 2 moles of proton. So 49 gram of H2SO4 will react with 40 gram of NaOH to consume each other, so that nothing left after the reaction. Well, this law of equivalent weight gives rise to another mathematical equation called the dilution formula or normality formula. That is N1V1 is equal to N2V2. Here N1 and N2 are the normalities of acid and bases, and V1 and V2 are the volume of the two solution which react completely. Now here if we have acid like HCl, it will give one equivalent H, and the base NaOH, it will give us one equivalent of OH. So both are equal in, you can say, magnitude, but the valency are difference, plus 1, here it is a minus 1. Okay, the equivalent weight in the normality formula can be written as here. Well, here equivalent weight, we know molar mass in a given in a gram or gram molecular arm. Formula mass or atomic mass if we have an atom, or ionic mass if we have ions like chloride, sulfate, etc. Number of replaceable entity, that is X. It may be H, OH, or number of electron gain or lost, number of cations, number of positive charges produced by any species. Okay, here we have NaOH. So the number of replaceable entity are 2. Equivalent weight is 40. Molar mass is 40. So 40 by 1 is equal to 1 molar mass. So for H2SO4, number of replaceable entities are 2. So equivalent weight will be 2. Equivalent will be 49, sorry. Well, here this 2 mean basicity or number of a replaceable entity. Well, here this one is acidity or number of replaceable hydroxyl ion. On now equivalent weight in detail. Well, you know the term equivalent means equal, you can say equal valency, substances of different weights that are having same valency but of opposite charges. Okay, F2 substance A and B, according to law of equivalence, F2 substances A and B are involved in a reaction. Then the number of equivalent of A, or here we will be talking about H plus, reacted will be equal to the number of equivalent of B. Here we will be talking about OH. No excess reactants of A or B will remain. Okay, in general from electrochemistry, actually the equivalence as this concept has been taken from electrochemistry, so we can define equivalent weight as the equivalence of a substance is defined as the mass of the substance that react with the R liberate 1 mole of electron, either react with 1 mole of electron or liberate 1 mole of electron. Here you can see NaOH produce 1 mole of OH, HCl produce 1 mole of H plus. The required number of equivalent. Well, OH and H plus have equal but opposite charges and they combine with each other chemically to produce H2O. Now, the equivalent weight of a substance element is that weight of the element that will combine with or replace directly or indirectly 1 gram of hydrogen, 35.5 gram of chlorine and 8 gram of oxygen. How? Suppose we have over here magnesium. This magnesium will react with oxygen. It will give us magnesium oxide. So here the mass of 2 magnesium is 48 and that of oxygen 32. Well, if we reduce it, then for 8 gram of oxygen we need 12 gram of magnesium, and this 12 gram is called the equivalent weight of this magnesium. As we have already said that for every 8 gram oxygen, the weight of any other substance that is combining with this oxygen will be equal to its equivalent weight. Like for 32 gram we need 48 gram of magnesium, for 8 gram we need just 12 gram. So 12 gram is the equivalent weight of magnesium. Remember, gram equivalent weight of an element is equal to mole or gram atomic weight divided by oxidation number. Suppose if we have sodium only, then it will be, if we have sodium only, it will be equal to Na divided by 1, mean 23 will be the equivalent weight. Here the gram equivalent of oxygen element is 16 by 8 by 2 8 gram. You can use these books for references. Similarly, here zinc is hydrogen is placed by zinc. Zinc is 68.5 gram. Zinc sulfate is 32.75 gram. So the equivalent weight will be here 2 hydrogen has been replaced. So 65.5, or you can say the valency of this zinc is plus 2, or you can also say that 2 hydrogen has been replaced. So 65 by 5 divided by 2 is equal to 32.75 gram is the equivalent weight of zinc. For aluminium, you can also find the equivalent weight is 27 by 3 is equal to 9.0 gram of aluminium. Mean that for aluminium you need 35.5 5 gram of chlorine, as this chlorine is required for aluminium, 9 gram of aluminium, so 9 gram will be equal to its equivalent weight. Remember, the gram equivalent weight of hydrogen is 1 and that of chlorine is 35.5. Well, equivalent weight is when expressed in gram, then it is called gram equivalent to weight or gram equivalent. It is actually obtained by dividing the molar mass of or formula mass of any substance by its replaceable entity. This replaceable entity may be proton, hydroxyl ion, etc. Number of electron gain or loss by species during oxide redox reaction. Number of cation species may be if sodium chloride is here. So the equivalent weight will be mass of sodium chloride divided by the total positive charge on sodium. Well, it depends upon the reaction. So we have different type of reaction like neutralization reaction, precipitation reaction, complex symmetric reaction, and each and every case the equivalent weight is different for these type of titration or reaction. So equivalent weight can also be represented as molar mass in gram, as we have previously discussed it. Here by X we mean number of proton produced, or if we have an acid, number of NaOH produced if we have a NaOH. Electron gain or lost for a redox reaction. Here it is for a sodium chloride type of compounds. Okay, each and every one will be discussed later. So if we have sodium, it's actually plus 1. So sodium 23 divided by 1 is equal to 23. Where plus 1 is valency of a sodium. Well, equivalent weight of a sodium chloride is 58.5 because we have a one replaceable potassium sodium or one chloride ion. Where for definition of equivalent weight we must know the behavior of a compound in a reaction. So we have different type of reactions and we will be having different equivalent weight. And you know that equivalent weight is different for different type of reaction. It actually depends on the nature of a reaction. So without equivalent weight or knowing the nature of the reaction, the equivalent weight cannot be determined. In case of acid base, actually equivalent weight is that weight of a substance that are to contribute or to react with 1 gram formula weight of a hydrogen ion in that reaction. Suppose if you have sodium hydroxide, so 1 gram of OH will react with 1 gram of hydrogen. Or mole equivalent will be equal to 1 by 1000 of the equivalent weight for an acid base and its salt the equivalent weight will be like for an acid. If we have mono, di or poly acids, the equivalent weight will be different. Depends upon the number of moles of hydrogen replaced. So it can be obtained by dividing molar mass of an acid by its basicity, mean basicity of an acid. Remember, 1 mole of hydrogen actually weighs 1 gram atom, which is equal to atomic weight of that hydrogen. So in case of HCl, we have 1 proton, so 35 by 5, 35.5 gram HCl. 1 mole weight of HCl is 35.5 gram. It actually produce 1 mole of HCl produce so 1 equivalent of a hydrogen ion. So the equivalent weight will be 36.5. Or you can also say that molar mass is 36.5 divided by 1. So the equivalent weight will be equal to 36.6. Simple one. 1 mole of HCl furnish 1 mole of H plus, and the number of moles of HCl is equal to equivalent weight of HCl over here. Number of molar mass is 35.6 and equivalent weight is also 36.5. It is 4. Here the equivalent weight is 98 divided by 1 by 2, because 1 mole of H2SO produce 2 moles of say proton. So 98 divided by 2 is equal to 49. So 49 is the equivalent weight of hydrogen. Now for H2SO4, 1 mole of H2SO4 produce 2 moles of proton, and 1 by 2 moles mean 49 gram produce 1 mole of proton. So this 49 gram of H2SO4 will react with the 40 gram of NaOH. So 1 equivalent of an acid is the amount of the acid that can furnish 1 mole of a proton. So by 1 equivalent we means the amount of acid that can produce 1 mole of H plus. Suppose if HCl produce 1 mole of H plus, so its equivalent will be 1, and H2SO4 produce 2, so its equivalent will be 2. While polyprotic acids like phosphoric acid, sulfuric acid and carbonic acid, the equivalent weight in such cases depend upon the reaction conditions. Here we have 1 NaOH and H3PO4 when react with it. Actually 1 proton is replaced, so the equivalent weight will be 98. If 2 proton is replaced, equivalent weight will be 49. If 3 electrons are replaced, equivalent will be 32.66, so on. Remember, the by basicity means the basicity of an acid we mean the number of replaceable hydrogen atom present in a molecule. Here another one is when H2SO4 react with Na2CO3 carbonic acid. Here in first case the equivalent weight will be 98 because 1 proton is replaced. If 2 protons are replaced, then the equivalent weight will be 49. Another example is carbonic acid. When it produces one proton, equivalent weight will be 32.0. If it produces two proton, then equivalent weight will be different. Equivalent weight of a base is actually the molar mass of a base divided by the number of replaceable entity. How? Molar mass of a base, acidity of a base, or number of replaceable OH ion. Here, in case of NaOH, 40 is its molar mass. Number of replaceable OH is 1, so its equivalent weight will be 40. Okay. And equivalent weight of calcium hydroxide will be 37.05 because dividing 70.15 by 2, the 2 OH ion are replaceable. So it will give us 37.05 gram. Well, remember that for final compound we use the word formula mass, and for molecular compound we use the word molecular weight or molecular mass. Well, equivalent weight of salt, actually by equivalent weight of salt we mean the number of positive ions or cation produced by that particular salt, or the equivalent weight or mass of a salt is that mass of it which contain 1 gram equivalent of the metal or its radical or cation, or the equivalent weight of a salt is numerically equal to the molecular weight of the salt divided by total number of positive ions. Here, sodium chloride, the molar mass is 58. Number of replaceable ion on 1, that is sodium or chloride. So 58.5 is the equivalent weight. Equivalent weight of calcium carbonate is 2 because here on calcium we have +2 positive charge. +2 positive charge. Example, calculate the number of gram equivalent and 40 gram of NaOH. The molar mass of NaOH is 40. We know that number of gram equivalent is equal to amount of solute in gram divided by equivalent weight. So put the values in the above formula. In case of a base, we will have 40 gram equivalent weight of that particular substance. Now coming towards the number of gram equivalent, it will be equal to 40 divided by 40 is equal to 1 gram equivalent. Assignment, please do these assignments and reply in the comments. Calculate equivalent weight for these acid, bases and salts, specifically iron sulfate, potassium H2O, heptahydrate. Assignment number 2, how can you prepare 0.1 normal solution of NaOH in 100 ml aqueous solution? The second one is, what mass of magnesium hydroxide is needed to prepare 1.50 liter of a 0.1 normal solution? Please comment. Thank you. Please like, subscribe and share this channel for more useful videos and information. See you on Monday, inshallah.